mode.
Good morning and welcome to CAD-1's Civil 3D Subassemblies and Subassembly Composer. My name is Stan Henne. I'm the Business Development Manager here at CAD-1, but much more importantly is on my left and your right, Brian Haley, our PE and Technical Specialist here at CAD-1 for Civil 3D, InfraWorks, and All Points Civil.
That's right.
So we're going to get started here. We have a few housekeeping slides to get us started, and then we will jump into the heart and soul of things. First off, most of you have probably been on a go-to meeting before, but one of the most important things, and invariably we always get somebody who's got their mic and speakers radio button on and they're trying to use the telephone and they can't hear us, so I don't know what good it's going to do to me to tell you this, because if you can't hear us, you can't hear us.
If you can't hear us, raise your hand.
Yes, there's the raise your hand button. Can you raise your hand and let us know you can hear us, please? There's a few hands going up. That's always nice to see that we aren't being totally ignored here in life. If you want to minimize your console so you can see the whole screen, it's now an orange and white arrow, but it is nonetheless an arrow which allows you to do that. Most importantly, you can ask questions during the webinar, and we will try and get them answered as close to in context as possible. So please feel free to type your questions in. And let's see here. We have, before we get to this slide, Autodesk, in their relentless drive to have promotions on their software, we are now into the second quarter of Autodesk's fiscal year, and they have a whole new promotion out. As many of you know, and those of you who don't, please pay attention. Autodesk will no longer be upgrading any software come February 1st of next year. That means if you have some older software and you want to keep its value and keep using it, you can keep using it, but it'll always stay your older software. You won't be able to upgrade it at any point after February 1st. So if you do want to keep it current, please get it on subscription and get it current sometime before January 31st of this year. Now that said, the current Autodesk promotion, you do get a 20% discount off of the upgrade software. Please call us for more details. This promotion just came out, so we don't have a slide for it right at the moment. Also, CAD-1 offers award-winning tech support. We have a full-time tech support staff, and we are here for you. So if you need technical support and a more personalized sort of technical support, please call us a technical support team. They start at a very low price of $3.95 a year. And yes, this video will be uploaded to our YouTube channel later. We record them, and then if the recording is successful, which we're pretty good at anymore, we will upload it, and it'll probably be up there in about a week or so. So, Brian, the next slide. We also, as many of you know, we are a Autodesk training center, and we offer a variety of programs, including a student training program. So often at colleges and universities, students have access to a computer lab, but they don't necessarily have access to a class that teaches them how to use the industry tools that they will be using in their careers. We have some special discounts for students who want to come to our training center. We are a Colorado state authorized school, and so we're just really good at this. And with that said, we talk about the Stanley Cup. Well, this is the Brian Cup, as we like talking about here, because so many of our instructors are named Brian. But that said, CAD-1 was recently awarded the top training center in North America for 2013, and 3 of our 5 instructors were also in the top 5 instructors in North America. All 5 were in the top 10. So we have a very good, very adept training staff, and we hope that you'll join us for a class or two if you need some additional training. And congratulations, by the way, Mr. Haley.
Thank you.
We have upcoming classes, Civil 3D Fundamentals. You can kind of read them there. Don't want to cut into Brian's time too much. Civil 3D Fundamentals class, May 19th through the 22nd. Styles class, the 27th. Grading class, the 28th. Pipe Networks, the 29th. Hydrology and Hydraulics, the 30th. And then we kind of start repeating the cycle again, Civil 3D Fundamentals, in early June. Now this is a new class for us, InfoWorks Fundamentals. InfoWorks is really gaining a lot of attention in the market, and so our InfoWorks class is a new class, but really an exciting product and really should be a good class. 12th and 13th of June. Then the CAD to GIS class, June 30th through July 2nd. We also want to let you know that we have our Customer Appreciation Day, which I forgot to mention to you, Brian, or to make a slide for. We have that on June 27th. We have some great speakers coming in from Wayne Hodgins and Autodesk Futurist. CSNA Architects will be presenting on the Broadmoor, the history of the Broadmoor and design at the Broadmoor, and Mark Hughes will be presenting from DIA on the DIA airport project. So a real good lineup. Our team will be doing presentations on the 2015 product, and then we will have the ever famous Battle of the Bryans.
That's right.
So we're looking forward to that, and it's free. Call us to sign up. With that, we have Mr. Haley is creating an Advanced Corridors class. That will be on the schedule shortly. And for our webinar listeners only, we are offering a special discount on this class. So $75 off that class. And we'll have that on the schedule shortly, and that'll be a lot of fun. All right, on to the real heart and soul here. Mr. Haley?
All right, thank you, Stan. So today we're talking about subassemblies and Subassembly Composer. One thing that I get a lot of questions like is, okay, I need to use Subassembly Composer to do this. Well, most of the time, honestly, you don't. Subassembly Composer is a great tool. It does fantastic work, but I would say 75–80% of the time when somebody says, hey, I need to know Subassembly Composer in order to achieve this certain task, they really don't need it. There are other ways of accomplishing basically the same thing without having to get into Subassembly Composer. So what we're going to do today is we're going to talk about some of these subassembly options. I'm going to briefly talk about some of them, show some of them off, and then we're going to get into the Subassembly Composer. So you could just use the default subassemblies. Just out-of-the-box subassemblies, no big deal. We're not really going to touch on that one much. There is this very specific one called the multi-link subassembly. This one just basically allows you to create a subassembly out of a subassembly. It's kind of a cool little tool. So I'm going to demonstrate this one. You can always use the generic links to just go through and create your subassembly, and basically you just sketch in your subassembly using the generic links. There's an option to create a subassembly from a polyline, so you can just go sketch in your polyline and make that into a subassembly. And finally, we can always get into the Subassembly Composer. Yeah, 99% of the time when people are doing assemblies, you can get by without the Subassembly Composer. If you need to start doing math, that's when you need to get into the Subassembly Composer.
Math?
Math. Oh, I love math. Math is awesome. I love math so much I even tell math jokes sometimes.
Oh.
All right, so before we get started with this, I have a couple of polls I want to run here. So just out of curiosity, especially since things are just getting released, what version of Civil 3D are you using? Are you up on 2015 yet? Any early adapters? You're still using 2014, which is I would expect to see most of you. Maybe you're 13 or 12 or earlier, and maybe you're not using Civil 3D at all. You're just here to check it out and see what all the fuss is about. Now I'll go ahead and close this, and we'll take a look at the results here. So not quite what I expected. I expected to see maybe a couple on 2015, but it's nice to see most people are at least on 2014. All right, so if you're not using the current version, are you planning to upgrade soon? All right, maybe you're going to upgrade as soon as you possibly can. All right, maybe you're going to wait for the first service pack. Maybe you're not planning on upgrading, you're just happy right where you are. All right, so I'll give you a moment to answer those. All right, I'm going to go ahead and close this down, and let's take a look at the results, which I find to be very interesting, considering nobody's using 2015, but there's some people that are using the current version. I wonder how that happens. Maybe they just missed the question the first time.
I think
many
people still feel
busy drinking coffee.
is the current version.
Yeah.
I will say to those of you who aren't planning to upgrade, please plan to upgrade by next January.
Yes, because you won't be able to after that. Yes. And finally, are you guys using any of the suites? If you're using Civil 3D and InfraWorks, then you probably have a suite. If you've got just Civil 3D, you probably have a suite. Maybe. You might. I don't know. All right.
That's interesting.
Unclose this. Let's see. Yeah. And go ahead and share that. So most people are using a suite. Some people aren't, and some people aren't sure what the design suite is. So the design suite, you have the infrastructure design suite, the building design suite, the production design suite, all sorts of fun design suites. Basically, it's a collaboration of software. Infrastructure design suite has things like AutoCAD, Maps, Civil 3D, InfraWorks, 3ds Max, raster design, things along those lines.
All for one happy price.
Yeah, it's wonderful stuff here. All right. So with that out of the way, let's go ahead and jump into here. So I'm going to start off. I'm going to use default subassemblies. I'm going to skip that one. I think pretty much everybody that's on this webinar probably already has a good idea of how this default subassemblies work. So let's talk about this multi-link subassembly here. So here I am in Civil 3D, and basically the approach I'm taking for this presentation is I have a haul road. So this is a haul road on a mine site. It's got 40-foot wide lanes, and I want to make sure that the trucks don't drive off the road. So I need to put a nice little berm over here. You know, it's basically you can think of this as curb and gutter for haul trucks. So it's a 6-foot tall earthen berm. And I don't even know if that would keep a haul truck on the road or not. But that's the approach I'm going to take. I'm not a mining engineer, so bear with me on this. If I do it wrong, I just kind of made up some stuff here. May not be real-world practical stuff, but it gives you an idea of how the subassembly composer works and things like that. So the first thing I want to do is I want to real quick show you multi-link subassemblies. So on your tool palettes, on the generic tab, what we have is the multi-link subassembly. This one's pretty cool. Let's see. So I select it. Over here in my properties, I basically just tell it how many links I want, and then width and elevation, change in width and change in elevation for it. So I'm going to put in 6 links. This is how my berm is going to look. I can type in the codes and things like that. And then, you know, honestly, I just put in my first one. So this is going to be 6 foot wide by 6 feet. Come on. By 6 feet tall. And I'm going to finish putting the rest of these values in after I attach it to my assembly, just so I can see it. So I'll go ahead and attach that off the edge of the lane. And so there's a 6 foot wide 1-to-1 slope. Now that I got it in here, I'm simply going to grab it and start making some changes here. So the top of the berm, I want to be 2 feet wide. All right. The next one is going to be 6 feet wide and go down 6 feet. And now I want to go straight down, so I'm going to go offset of 0. All right. Oh, sorry. Offset of 0 with a change in elevation of 4 feet. And then I'm going to go back. So I went over 6, then 2, then 6. So I'm going to go back 14 with a change in elevation of 0 again. And then I want to go back up the 4 feet, back up to where I was. And I did, oh, that was wrong. That should have been 0. Sorry. That one should be 4. No, that one should be 0. That one should be 4. There we go. And once I get back to the beginning, you can see it fills in the area with the shape. So this is one method of creating an odd-shaped subassembly. It's pretty straightforward, nice and easy. I'm going to show you another way real quick. So another way is I can simply draw on a polyline. All right, so let me go ahead and draw my polyline in here. Okay, that was quick. Wasn't that awesome? Don't you just love look behind the mirror type things? All right, so I got this polyline here. It's just a polyline. It basically represents the same thing. And what I'm going to do is I'm going to make this into a subassembly. So on the Home tab, Create Design, I can create a subassembly from a polyline. All right, grab the polyline. You get some options in here. I'll call this one berm or whatever you want to call it. And now it's a subassembly. Now, when you're doing the subassembly from the polyline, you have to go in yourself and add in all the codes. Oh, and besides that, you can see that the attachment point is right there. No. It needs to be over here. So I'll go modify the origin, make sure it's at the right spot, and then I can come in here and I can start adding codes to this. So the code, along the top is going to have the top code, so I'll call this the top code, and I want that link there to have the top code. And then I want this link to have a top code, and then I want this link to have a top code. And then I could also add, point codes and things like that. I want to put a shape in here, so I can tell it to, hey, I want you to have a shape. I select the links that form the shape. And then I can add a code to the shape as well. So this would be dirt. I know that's not a good code because technically it's not dirt, it's soil. All right. And now if I go into the subassembly properties under the codes, you can see I've got my top code. I don't have any point codes because I haven't added any. And I've got my dirt shape code. Right. No, I don't refer to it as cement. Cement is an ingredient in concrete, even though I do refer to dirt as dirt. All right, so there's a couple of different ways of creating subassemblies. Again, these are real quick, real easy. The next method is just to use your generic links.
I was hoping you'd name your subassembly Joe.
Call it Joe Dirt. So I'm going to use generic links. So I'm going to come over here to the other side, and I'm just going to use a link width and slope. All right, so my width is going to be 6 feet. My slope in this case is going to be 100%. And I'll attach it here. And you can see I can simply start building out my subassembly. This is going to then be 2 feet with a slope of 0. And that attaches right there. And then again, we'll go 6 feet with a slope of minus 100%. And so I can start building out my subassemblies. Now, there's advantages and disadvantages to all of these. Let's talk about some of those. So here I've got the multi-link subassembly. The advantage to this one is it's really easy. A disadvantage is, well, it only has one set of codes. So all of the links have the same code. All of the points have the same code. I can't put in multiple codes. I can't define this is top and this is datum because, well, they're all going to be the same. So that's the disadvantage of it. Here's the one created from the polyline. The nice advantage about this one, again, it's easy. The other advantage is I can put multiple codes. I can assign different codes to the different links and the different points in this case. Right. The main disadvantage to both of these, both the multi-link as well as the create from polyline, is they're not parametric, which means they can't change. So if I need to make the top wider in certain areas. I can't do that because they're static. They're not parametric. The advantage to the generic links is it's fully parametric. I can change widths and elevations and all sorts of fun stuff like that. Disadvantage, I can't put a shape in here.
And Brian John has a question here. What if your subassembly is double shape, i.e. below is a subbase when using a polyline?
So, John, the question, I believe, is what happens if I wanted another piece underneath here? I have quick yes or no? All right, so that would be another subassembly in this case. So I'm creating it from a polyline. A polyline can't split. So I'd have to create a sub-base piece under here as its own subassembly. Good question, though. So that's another disadvantage to it. The same with the multi-link. It has to be one enclosed area, I believe. Never tried it otherwise. But again, the disadvantage to using the generic links is no shape areas. Okay, we got another question. Hang on, let me read it here real quick.
Okay, Jeff asks, I want to create a basic line so that the slope from center out will tie into existing surface. I want the lane to show up as shape in section as a solid. And then, yeah, we saw that, but we won't hold it against you, Jeff.
I want to create a basic lane so the slope from center out will tie into the existing surface. I want the lane to show up as a shape and a section as a solid. I would just use your, so in that case, Jeff, what I would do is I would just use your basic lane. And then I would also use a link to surface. And you can get an output from the link to surface and use that as an input to the lane. It's a little bit outside the scope of this discussion, but it definitely can be done. So if you go into your assembly properties, just real quick, let me show this. All right, on your construction, you have output values. So you can get a slope and a width from an output value and use that as the input value for a lane. So, all right, let's hold off on questions here for just a bit. Let me get into a little bit more.
Go ahead and type in your questions, but we'll
keep asking questions. We'll address them
in a minute or two.
So if you ask a question, I'm not answering it right away. Just don't hold it. Nothing personal.
He is ignoring you. He's that way.
All right. So here are just basic in the drawing, no subassembly composer. I want to create some subassemblies. Now, what I'm going to do now is I'm going to get into subassemblies, the subassembly composer. It looks scary. So it's foreign. It's weird. It's odd. It's a flow chart. That's really all it is. You start at the start and you work your way through. That's all there is. So in this case, what I'm going to kind of do something a little bit different with my little earthen berm there. So I made up some criteria for it. So here's the criteria. If I'm in a fill situation and it's less than 2 feet of fill, well, let me put it this way. The minimum height I want on this berm is 2 feet. The maximum height I need is 6 feet. If I'm less than 2 feet of fill, I just want to put in a 2-foot of berm. If I'm more than 6 feet of fill, I just want to put in a 6-foot berm. But if I'm somewhere in between, I want the height of the berm to be the same as the depth of fill. So if I'm in 3 feet of fill, I want the height of the berm to be 3 feet to give me a little bit added protection for that severe drop-off. I know it's kind of maybe not so much a realistic real-world application, but I think this is a good example of how these tools work. So if there's any mining engineers out there, please don't actually design this way, because I just made this up last night. All right, so basically what I'm going to do here is I opened up Subassembly Composer. It opened up a new subassembly. The first thing I have to do is tell it what it is. So on my packet settings down here, I'll give it a name. I don't want this to be Subassembly 1. I want this to be Hall Road Berm. Give it a name. All right. You can give it a description. If you have a help file or an image, you can add that here. I don't in this case, so it's going to be kind of boring, but anyways. And then I've got my input-output parameters. So when I input, so in a subassembly, you got all those input parameters. What parameters do you want? Well, I want to be able to specify the depth below the attachment point for the thing. So I'm going to create a parameter here, and I'm going to call this one base depth. It's going to be a double, which is a number, and my input value, I want it to be by default 4 feet. The side, I'm going to have it default to the right side. And then, let's see, I got some target parameters. I need to be able to target the existing ground in this case. So I'm going to create a parameter, call it, I don't know, say existing ground. And it's a surface, existing ground, no spaces. It's a surface, and my preview value here is going to be, say, 4.5 feet. So about halfway between the 3 and the 6, right? Oh, sorry, minus 4.5. And you can see up here in my little preview, I've got my assembly, and then I got the existing ground. So now what I want to do is I basically want to calculate the depth. How much fill am I in? So the way I'm going to do that is I'm simply going to use auxiliary points. So auxiliary points are just points that are out there that I can use for calculations. So I just simply take my auxiliary point and I drag it in. So auxiliary point 1 is going to be right there at the origin. Auxiliary point 2, and you can see it's to make that flow chart for me, is going to be from auxiliary point 1. And it's going to be a delta x on surface. What's my delta x? Well, 0. I just want to see it on the surface. All right, so if I come over here and I zoom in a bit. Oh, sorry. What did I do? Oh, I got to set my target surface. It's going to target the existing ground. So you can see I've got auxiliary point 1 and auxiliary point 2 with this link. So that's going to allow me to do math. I said math. It's cool, right? So what math do I want to do? Well, I want to know the depth here. So what I'm going to do is I'm going to define a variable. All right, what is this variable going to be? Well, it's going to be the distance from the y value of AP1 to the y value of AP2. So my variable type is going to be a double. Again, that's a number. And my expression is going to be AP1.y minus AP2.y. So what's the elevation difference between these 2 points? And I did something wrong. AP1.1. Oh, no, I'm sorry. Why am I still getting the little warning? Oh, I got to give it a name. It helps if you give it a name. So I'm going to call this one basically DH delta H, right? And now my little warning symbol goes away. So if you get that warning, you've done something wrong. So now, depending upon the height, I want to do different things. So I'm going to put in a decision. I'll just kind of organize this a little bit. So what is the decision? Well, the first decision I want to do is the elevation, is this DH more than 6 feet? So the condition is DH is greater than 6 feet. All right, and then I got a true and a false. So as I mouse over this, you can see I got a true branch and a false branch. It's a flow chart. So let's see, what do I want to do here? And I just start building this out. Now, the way I'm going to do this here is I'm actually going to put in another variable. I should have done this before. All right, I'm going to go put in another variable here. I'll just define another variable. I want it to be between here. Now, what it did is it went from the true up to here. I don't want that. I'm going to reconnect some of these things. I can just erase these, and then I want to go from there. Come on. Go from there to there, and then I want to go from this variable to my decision. And this variable is going to be, oops, didn't want to double click in it. This variable will be firm height. Variable type is going to be a double, and my default is going to be 6. All right. So if it's that, I'm setting the value here. So if this is greater than 6, well then I don't really need to do anything, but actually let me, yeah. So I'm going to set a variable if it's true. If the variable, just to make sure, I want the variable to set is berm height, and I want it to be equal to 6. If it's false, I want to put in another decision. So I'll get rid of that, and then I'll connect the false to the input here. And I can always rearrange these and try to make them look a little bit better maybe. So again, if it, in this case, my decision is going to be, is DH less than 3. All right. If DH is less than 3, again, I'm going to put in a variable. And this time the variable is going to be berm height, and it's going to be equal to 3. And if it's false, let me go ahead and make this a bit bigger, getting long here. If it's false, and I then want to put in a set variable value again, put this over here on this side, and I'll connect that to that. Oops. Let's try to organize things up here a little bit better. Shift you over. All right. In this case, I want to set the DH to, well, what do I want it to be? Well, I want it to be equal to the DH. I'm sorry, I want to set the berm height equal to DH. Now, I got everything set up, I can now go in and define the actual geometry. And the way I'm going to do this is I'm going to put in another flowchart. Just put in a simple flowchart. Now, I want all 3 of these to connect here. So I'm going to grab this one, and we'll connect to the flowchart here, and we'll connect this one. So no matter which path I go, I end up here, but I end up here with different variables. So now within the flowchart, I simply start putting in my geometry, in this case. So I'm going to put in a point. Where is this point? Well, it's going to be at the origin. I put in another point, and as I drag in the next point, this is now going to include a link. And down below, what is my delta x going to be? Well, I want it to be equal to the berm height. I want to go over 6 feet, up 6 feet. So my delta x will be berm height. GHT. There we go. And again, over here in the preview, we can see it starting to work. And my delta y is also going to be berm height. Put another link in. I want this to have a 2-foot top. So this delta x is simply going to be 2. Put in another point, and I just start working my way down. This one, the delta x is going to be berm height, and the delta y will be berm height times a -1. All right, now, this is where it gets a little fun. I want to come down my base depth. So I created this base depth input parameter. I want to come down that distance. Now, what happens if they put in a positive number or put in a negative number? Well, I don't care which way they put it in. I want it to always go down. So for my next link, again, I'm going to do some math. And I even actually get a type math, so this is awesome. All right, so my point 4, my delta x is going to be 0. My delta y is going to be math dot absolute value of base depth times a -1. So no matter which direction I typed it in, I want to take the absolute value of it, and I want it to go down. And it goes down the deep 4 feet in this case. And now one more point. This is going to represent coming back over to this side. This delta x is going to be 2 times the berm height plus 2. So it's going to be berm height times 2 plus 2. Oop. Wrong way. Times a -1. And now all I want to do is put in one final link, and that'll connect back up to the beginning. So this one I want to go from point and go back to the beginning. So there's my links. Now I can go through and put codes and all sorts of fun codes on these. One last thing I do need to do is I do want to put in a shape. And this shape is going to be composed of this area right there. So I click that point, and it allows me to put in my shape. Now, how's this going to work? If I change the existing ground here, so I can actually take this and drag this up and down. As you can see, as the ground gets deeper, the berm gets higher until I reach a certain point, and it stops. I start moving up again, the berm gets lower until, again, I reach a certain point, and then it stays at that minimum height. So let's go ahead and take a look at this actually in Civil 3D now. Oh, so sorry. First of all, what I have to do now is then save this as a PKT file, as a packet. So I do a save as, and I save it as a packet. So I've already got this variable berm packet in here. This is the one I'm going to use in Civil 3D. So now I'll come over to Civil 3D. I've got this nice haul road, and here is that subassembly brought into Civil 3D. And what I did is I threw in a couple of conditionals, so make sure that this is only put in a fill situation. And I'll come down here and I will take a look at my section editor. So as you can see, here is the berm, and what I'll do is I'll make sure I'm always zooming to this offset and elevation. And as I step through, must be going the wrong way. There we go. That is the other side. Let's take a look at the other side. I think the other side works better. As I go through the section here, you'll see that berm get bigger and smaller. So as it gets more fill, you can see that berm start to grow out. And doesn't seem to be real obvious here. Let's go ahead and close out of this. I thought I had this bit more. Let me do something here real quick. Sorry. Yeah, we should have lots of fill there. Am I just not seeing it? All right, I'll start here. One more time. Section editor. As I start stepping through this, you should see that berm start to get wider and taller. There we go. It's getting wider. And then it'll start getting smaller again. So it's all dependent upon the depth of fill. So there it is at its max. As I continue to step through, it'll start to shrink again once we get less fill. There it is down towards this minimum.
Now, Brian, I can see that you, get closer to the mic here, I can see that what you meant by there's lots of times you don't need the subassembly editor or composer, but I can see some real value to creating consistent subassemblies perhaps for your organization and so forth. What do you think the times where people most could use a subassembly composer in an organization?
I think they're not really going to be, or you're not going to create a set of subassemblies for the organization. These are going to be more project specific. This specific project, we've got this thing going on. I need a subassembly that does this. Not saying that that's not always going to be the case, but that's where I see it going to be used the most. Mm-hmm. Yeah, so it's definitely going to be a project-based type of a thing, and it's like I said before, it's going to be those situations where you got to do math. If you don't have to do math, you can probably get away with using other methods. I saw a great example of creating a subassembly that does a daylight so that the maximum slope is 4:1. Now, we've always done 4:1 side slopes, but what happens if your road is going down at 8% and you got a cross slope going at 4:1? Well, then your resultant slope is going to be greater than 4:1. So I need to do some math. What does take into account the slope of the road and my cross slope and flatten that cross slope out so that I don't exceed 4% or 4:1 slope on my side slope. So that's another example of where you can use Subassembly Composer. There's lots of examples out there. One thing I did not show is once I get the subassembly created, well, how do I get it into Civil 3D? This is done through your tool palettes. So what I would do is I would create my own palette. I'll just right-click on here, create a new palette. All right, name it whatever you want, and then you simply right-click on the palette name and import the subassemblies. And then you can browse to that PKT file, and hopefully you've included an image in it so you actually see something there. And there is that haul road berm that I created earlier.
All right, well, we've got a few questions. Are you ready to
go ahead and do some
tackle
questions?
them right now?
Absolutely.
Okay, Jacob's question goes back to earlier in the session here. He asks, is it possible to change the origin of a multi-link?
So the multi-link, let me switch back over here real quick. So I've got the multi-link. So is it possible to change the origin? No. Basically, your D1 is where the origin is. So if I wanted the origin to be up here, well, I would just need to start putting in this list as though I'm starting here. So you just need to do it in the order that this is done. So the D1 and the Z1, that is, going to specify the first point from the origin. So it all depends upon where you start this list at. So.
Okay, so a little bit of planning is at hand there.
Yep.
Amy asks, would this method also work for a channel that goes up at 3:1 to a variable wall height? The wall is coming off a sidewalk that comes off an X curve, and her question came in during the Assembly Composer.
All right, so would this method also work for a channel that goes up at 3:1? Yeah, I see no problem with doing something like that, Amy. You probably do it all as one subassembly, so the wall and the channel side slope might need to be one subassembly, but it definitely could be done.
Okay. John asks, it could help for a retaining wall for variable depth and height, and that kind of goes back to Amy's question too a little bit there. So.
Yeah, so I've seen quite a few examples where the subassembly composer is being used for retaining walls. One example is if I'm in certain depth ranges, I want to put in different shapes on my wall. So if I've got less than 3 feet of fill behind my wall, I don't need a key at the bottom of my wall, but if I'm more than 10 feet or between 3 and 10 feet, I need that key in the bottom of my wall to keep it from sliding. So you can do things like that as well within the subassembly composer.
All right, Joe asks, are there any out-of-the-box subassemblies, berm or walls that use this kind of internal logic to establish the berm height?
Not that I know of, Joe. So this variable height thing that I was showing here, where the size of it changes based off of the depth. Again, this is doing math, and none of the out-of-the-box subassemblies really do this sort of thing that I'm aware of. That's kind of why I chose this example. All right,
David has a few questions here. First question, are the custom subassemblies backwards compatible, like 2015 to 2013?
I don't know. I haven't tried. Unfortunately, I don't have older version on this particular computer, so I can't try it, but that's something I'd have to look into. My gut tells me that they might be. I'm not going to say they are. I'm not going to say they aren't. No, I'll take that back. My gut is just upset. That's been something I ate this morning, so ignore my gut.
All right. Again, do you have a sample for report message?
So the report message, I'm assuming you're talking about, is this here. So what I could do is I could put in a test. So if I go back up to my flow chart, I can put in a decision that says, hey, is the DH less than 1, less than 0, which in this case would mean that we're in a cut situation. And in that case, I could put in a report message saying, hey, this subassembly shouldn't be used for this situation, and it would show up in my event viewer for the report, the report message.
Okay, and then last, does having vertical links in a subassembly create a problem with your corridor surface?
Ooh, that's a good question. Does having vertical links in a subassembly cause issues with a corridor surface? It depends. If you've taken one of my classes, no, it doesn't, because you know what to do. Because this is something I always talk about in all of my classes. So if I were to create a corridor surface here, and I'm just going to create one here real quick. What you should always do whenever you create a corridor surface is put in an overhang correction. I don't care if there are overhangs or not. Always put in an overhang correction. Which one should you put in? If you don't know, it doesn't matter. Put in a top link, put in a bottom link. I don't care. It doesn't matter to me. At least put one in. So if you have vertical links, putting in an overhang correction will allow it to be very vertical-y. It can't be vertical. The surface can't be. But this is as close to it as we can get. So if you have vertical links, make sure you put in an overhang correction. If you don't have vertical links, I would still recommend putting in an overhang correction because you might end up with a vertical link somewhere. So just good practice to put in an overhang correction in your surface.
There you go.
All right.
Well, Brian, we don't have any more questions right now. Do you have anything else you wanted to show, or?
No, that pretty much covers it. Unless, well, I'll hang out here for a few minutes to answer any questions.
All right, real good. We will be recording this, and as I said, we will be posting this to our YouTube page, and it will be available on our either through the YouTube page, or you can go to the CAD-1.com and webinars archives, and you can find it there. And if you want to Twitter with us or Facebook with us, or look at Mr. Haley's blog, Civil 3D Plus, which is a very good blog. There you go. And you done moving slides around now?
Yeah,
You got to quit screwing around so people can see?
Just trying to read some of the questions, that's all.
Okay, we got a couple more questions.
Oh, okay.
Let's see, David asked, can we go briefly over the advanced geometry in Subassembly Composer? And then Scott asked, can you spend some time on overhang correction? And John asked, could you explain encoding in a polyline? So we got three good questions there.
So the advanced geometry, this is, if you want to put in a curve, again, it's just basically you grab the piece that you want and you add it to the subassembly. Is there anything really to explain? It's pretty self-explanatory. I mean, offset geometry is, I create another thing offset from that. So if I was putting in a street and I wanted to put a link offset from it, for maybe base or sub-base or something along those lines, I could do that. Get marked the daylight rounding, so if I'm doing a daylight, I can put in the little rounding to make it not quite so angular. Surface link, I link to a surface. Curve, now subassemblies can't have curves, so this actually puts in a bunch of little line segments. Really there's, again, if you want to add it, this isn't going to make a whole lot of sense, but you add it in, and then, you fill in the properties of it. So this could be an arc general, 3-point arc, or a general parabola. And then I get my arc tessellation and things like that. So you just drag and drop the pieces in, and you go from there.
Okay, Scott asked, could you spend some time on overhang correction?
Overhang correction. Let me, oops. No, I don't want that one. That was a basic. Don't use basic. Use the primary road. Where is it? Oh, there it is. That's what I was looking for. All right, overhang correction. So if I create a surface out of my datum links, where are my datum links? Well, I've got a datum link that runs down here on the bottom of my lane. I got a datum link that runs here for my curb and gutter, and I got a datum link that runs here for my daylight. Problem is right through here, that's not the color I wanted, I actually end up with an overhang of two different assemblies, or two different links. This is bad. We don't like this. So my overhang correction basically says, okay, which one's right? Because what happens if I don't do anything here? I end up with a surface that does something like this. Have you ever seen that? So it just goes from datum point to datum point to datum point to datum point to datum point. And so an overhang correction will come through and say, oh, we got an overhang, which one's right? Well, the top links are right. And it'll do that. All right. Or it'll come along and say, oh, you got an overhang, which one's correct? The bottom links are correct. And so it'll do something like that, which is a lot better than this thing.
I should say so.
So that's overhang correction in a nutshell.
Every time I hear that phrase, I think of Austin Powers. John asks, can you explain coding in a polyline?
So, John, I'm assuming you're talking about adding codes to a polyline. So, yeah, you just grab the subassembly created from the polyline, and then you add the codes that you need. So do you want to use a top code and a datum code? Do you want to use a daylight code, a hinge code? So if you go into any of your other subassemblies, so I'll just go to my curb subassembly here, go to the help for it. And I scroll down to the bottom, you'll have all these codes for the subassembly, right? So just using that add codes in in here, you can add in those codes to your own subassembly created from a polyline.
All right. We have a civil chat coming up. It's not until July, I think it is this time.
I'm not sure when it is.
Right. Well, civil chat's a great program where you can kind of free-form your questions, and I'm not sure when the next one is, but usually we have it once a month. I think it's early June because you guys are going to be at tech camp for the next couple of weeks here.
Yep.
Anyway, Trudy asks, we have been trying to model road turnouts and having trouble with transitioning between the normal width and the turnout. What would be your suggestions?
I would use a target for my lanes. So again, if I go to the help for my lanes, so I'll just go to my help for my lane. Depending upon the subassembly you're using, do not use the basic subassemblies. I should have mentioned this. Don't use. So you got the basic tab here. All right. Don't use these. They're just horrid. Please, just don't. Why? Well, here, let me show you. Let me go to the help for the subassembly, and in the help for this subassembly, right here, it says, hey, this subassembly is one of a group of getting started subassemblies used for simple roadway modeling and for tutorial and training purposes. This screams at me, don't use this in production. So don't use your basic subassemblies. All right, so here's my lane, and what you can do is you can have this width change based off of geometry in the drawing. So I can have this width target a polyline. So I would just draw a polyline that represents how wide I want the lane to be, and it'll just go out and target it. And then Joe asks, are there any new subassemblies that they've added in 2015 that you want to mention? I don't know of any new subassemblies in 2015. They've made a couple of changes to Subassembly Composer in 2015. You can now create shapes that have holes in them. Like for example, if you're creating a subassembly for a pipe, and you wanted the shape that's around the pipe, you can do that now in the Subassembly Composer. But no new standard subassemblies that I'm aware of. I'm not saying there aren't, I'm just not aware of any.
Or we don't want to mention them. All right, folks, any additional questions here real quick, type them in, and otherwise we're going to bid you adieu. Looks like we're not getting any more questions. So, folks, thank you very much. We appreciate your time today. Hope this was helpful to you, and we look forward to seeing you on future webinars. So, thanks very much. And Brian, thank you for preparing this, and we will say goodbye now.
All right. Thank you, everybody.